Now let's have the derivative of the inverse trigonometric functions. Now let's take a look at the table that we have here. So we have here the basic trigonometric function sine x and its corresponding inverse, which is arc sine x, or denoted by sine raised to negative 1x. We have cosine x and its corresponding inverse, arc cosine x. Tangent x and its corresponding inverse, arc tan x. Cotangent x and its corresponding inverse, arc cotangent x. Secant x and its corresponding inverse, arc secant x. And cosecant x and its corresponding inverse, arc cosecant x. Right? And we also have here the derivatives of the inverse trigonometric functions. We have here the derivative of arc sine x with respect to x is equal to 1 over the square root of 1 minus x squared. And if u is a differentiable function of x, then the derivative of arc sine u is equal to 1 over the square root of 1 minus u squared times the derivative of u with respect to x. So if we are looking for the derivative of the inverse trigonometric functions after we have identified our inside function or the function within our inverse function, then all we have to do is follow the formulas that we have on this column of our table. Let's move on to our examples. Okay, we have here, find the derivative of y equals arc sine 3x. So first thing is we have to identify our u, which is the function inside or within our inverse function, and that is 3x. We let u be equal to 3x. And now we can start solving for our derivative. So going back to our table, okay, the derivative of arc sine u is equal to 1 over the square root of 1 minus u squared times the derivative of u with respect to x. So we can start it with the formula. The derivative of arc sine u is equal to 1 over the square root of 1 minus u squared times the derivative of u with respect to x. Now we can substitute already our u to our formula. So the derivative of arc sine 3x is equal to 1 over 1 minus our u, which is 3x, times the derivative of u, which is 3. So here, multiply, so we have 3 over the square root of 1 minus 3x squared, and that's 9x squared. That's already our final answer. Now let's move on to our second example. Find the derivative of y equals arc cosine 3x squared. So first, let's identify our u. So our u now is 3x squared. So let u be equal to 3x squared. And then we can start solving for our derivative. So let's go back to our table and find the formula in finding the derivative of arc cosec cosine u. So according to our table, alright, so we have here the derivative of r cosine u is equal to -1 over the square root of 1 minus u squared times the derivative of u with respect to x. So let's use that formula. Okay, so the derivative of r cosine u is equal to -1 over the square root of 1 minus u squared times the derivative of u with respect to x. Now we can start substituting u to our equation, to our formula. So we have the derivative of r cosine 3x squared with respect to x is equal to -1 over the square root of 1 minus u is 3x squared, squared times the derivative of u, which is 6x. Now let's multiply -1 times 6x. So we have here -6x over the square root of 1 minus 3x squared is 9x raised to 4. Rewriting our final answer properly. So we have here the derivative of r cosine 3x squared is equal to -6x over the square root of 1 minus 9x raised to 4. And this is already our final answer. Now let's have our third example. Find the derivative of y equals r cotangent 4 minus 3x squared. So first thing, let's have to identify our u. So we have here solutions. So let our u be our inside function, which is 4 minus 3x squared. So let u be equal to 4 minus 3x squared. Now we can start solving for the derivative. So we have the derivative of r cotangent u is equal to, let's go back to our table, and the derivative of r cotangent u, is equal to -1 over 1 plus u squared times the derivative of u with respect to x. So let's go back. So that's -1 over 1 plus u squared times the derivative of u with respect to x. Now we can substitute u to the formula. So we have the derivative of r cotangent 4 minus 3x squared is equal to -1 over 1 plus our u is 4 minus 3x squared. So we have 4 minus 3x squared times the derivative of our u, which is 4 minus 3x squared with respect to x. Now we have 1, negative 1 over 1 plus 4 minus 3x squared is equal to 16 minus 24x squared plus 9x raised to 4 times the derivative of u. The derivative of 4 minus 3x squared is just negative 6x. Multiplying negative 1 times negative 6x, we have positive 6x over, combine like terms in our denominator, so we have 1 plus 16 is 17 minus 24x squared plus 9x raised to 4. Or we can rewrite our denominator in standard form. So our derivative now will be equal to 6x over 9x raised to 4 minus 24x squared plus 17. And that is already our final answer. And that's it. That's how to find the derivative of the inverse trigonometric functions. All you have to do is to take note of the formulas that we have on our table.